Okay, topic 7, the cardioid. You've already seen a cardioid in the previous graph or in the previous video. We did a graph of a cardioid using the calculator. So what we want to do here is just kind of highlight and feature the equations that you could see. It's really helpful if you can kind of get used to some patterns of equations. I'm not saying you have to like completely memorize them because you do have your calculator to assist you, but it's always nice if you can like recognize things. So the equations come to us in the form r equals a times, in parentheses, 1 plus cosine theta, r equals a times 1 minus cosine theta, or r equals a times 1 plus sine theta, or r equals a times 1 minus sine theta. Now, a has to be positive, okay? And these graphs are going to go through the pole at some point, so they're going to touch or go through the pole, okay? Now, you will sometimes see the a distributed. So it would not be unheard of to see a plus a cosine theta, a minus a cosine theta, or a plus a sine theta, a minus a sine theta. Like you'll frequently see this format. So don't be alarmed if you see it. It's the same as these. It's just in the top, the a has been factored out. In the bottom, the a has been distributed through. Okay. So example 8 says graph each polar equation. What do you notice about the two graphs? So we'll talk like symmetry and then like things like that. Okay. We are definitely going to use our calculator. Okay. You could certainly do like a point plotting situation, and we have two at the end where we're going to do the whole point plotting situation, and then you're going to really appreciate what your calculator can do then, okay? So we have r equals 4 plus 4 sine theta. This is the exact same as r equals a plus a sine theta, or r equals a times 1 plus a sine theta. So we're or not a, just sine theta. Okay, so we're definitely in the right format for a cardioid. Okay, let's just go ahead and go to the calculator. Now, please remember my setup is not ideal. I can't do like the dual screen thing, which I yearn for the days where I can figure out how to do the dual screen thing. But for now, we'll just flip flop. Okay, so let's mosey. Now, you need to make sure that your calculator is in radians mode and polar mode, okay? So when you go to the mode button, you want to make sure you have radians highlighted, and then in the fourth line, you want to make sure it's not got function highlighted, it's got polar highlighted. Now, if you ever need to go back to graphing stuff in our regular, like familiar rectangular world, you will need to go back here and change back to function mode, okay? But we're good. We're in radians and we're in polar. So we want to go to y equals, and we want to type in 4 plus 4 sine theta. And remember the button that ordinarily types in your X, once you put it in polar mode, it's automatically going to do the theta. Okay? Now, we have our window set from the previous example. So I like my theta. My theta is 2 pi, negative 2 pi to positive 2 pi. My theta step is 1 over 2 pi. X min, X max, Y min, Y max, we may have to tweak those a little bit, but let's just go ahead and see what we can see for now. So let's go to the graph, and it looks like a rear end, and I did not plan that very well. I'm like almost mortified. But anyway, we definitely need to go wider on the x-axis, and we don't really need to go lower on the y-axis. We need to go higher on the y-axis. So we need to change x min, x max, and y max. Okay? So let's say we go, I don't know, let's do like negative, oh, I don't know. Let's do like negative 8 to positive 8. Let's see if that's enough. And then we didn't really need to change the Y min. We definitely needed to change the Y max. So let's change Y max to like 10. Let's see if that's enough. Okay, so there we go. We can see our graph a little bit better. And remember, if you go zoom square, option 5, it's going to kind of square out your graph. It's going to make it look, it's going to tweak the X and Y axis so that you have something that's squared and not kind of like pulled the wrong way. Okay, so there is our sweet little cardioid. Okay, we can remember as long as you go into that polar grid situation on your calculator, you can do the trace button and you can find different values for R based on whatever you choose for theta. So if you go second format or second zoom, which takes you to the format screen, make sure you're in polar. And then you can, when you go to the graph right here, we can go second trace and use the value function, and we can type in values for theta. And now that we're in this polar grid situation, it'll spit out values for r. So if we go second trace and choose option 1 for value, it lets us type in values for theta. So let's do pi over 2. So we want to go second caret divided by 2. So pi over 2 is kind of an easy one. You can see that we're crossing for us, what we're typically thinking of as the y-axis, or this like where we have pi over 2, we're crossing at 8. Okay, we could check any value we wanted to here. Notice we go out 1, 2, 3, 4, 5, and like a little bit over here. So we definitely are dealing with a symmetry situation. We for sure have symmetry about pi over 2, okay, or the y-axis is what we're more familiar with. So there's definitely a symmetry here. It is definitely about the y-axis or pi over 2. There is no symmetry about the polar axis or the pole, but we do have this symmetry here. Okay, and it should kind of make sense. That's the y-axis, and we're dealing with a sine function, and it's kind of wrapping itself around the y-axis. Okay, so let's go back to the worksheet. Okay. Now, unfortunately, the polar grid that I gave you isn't actually large enough to take in this graph. So let's see. We are from the pole, we go up 1, 2, 3, 4, 5. We could go 6, 7, 8. So our graph goes way up here. And then we could go out 1, 2, 3, 4, 5. Our graph is going to go a little beyond 5 in both directions. So we're going to have something kind of a little bulbous. It's not the best graph I've ever drawn. It's also not the worst. Okay, so there you have it. That is 4 plus 4 sine theta. You could also think of this as r equals 4 times 1 plus sine theta. Okay, so if you saw either of those formats, you should kind of in your head think cardioid. Okay, over here we have r equals 2 times 1 minus cosine theta. So you could also see this as r equals 2 minus 2 cosine theta. You have a is 2. It's definitely more than 0, so we're good. We can go to our calculator and see what we're working with. So let's go back to the calculator. We are already in the right modes. I haven't changed anything in the last 10 seconds. So let's go to y equals. We need to get rid of this equation. So we want to type in 2 minus 2 cosine theta. You could also, if you wanted to, do 2, well, instead of distributing the 2, you could do 2 parentheses 1 minus cosine theta parentheses. It'll be the same thing. And then we can go to our graph and see if we need to tweak our window. All right, so I'm going to tweak my window a little bit. I don't need the Y max or the X max to be quite so dramatic, or the Y min. So let's tweak our window. Let's say we go maybe -5 to 5. And then we can do like maybe 5 here. Let's just see what that does for us. That's a little bit better. Let's square it out. So zoom 5. So there we have our cardioid. Notice this one, we're definitely dealing with a situation where we have symmetry. In this case, the symmetry is about the polar axis or the x-axis, which is what we're more familiar with. Okay, and that should kind of make sense to us because this graph involves cosine and it's kind of wrapping itself around the x-axis. So let's see. We go 1, 2, 3, not quite as high as 3 or -3, and we go back 1, 2, 3. We go -4 on the x-axis, and then not quite to 1 in the positive x-axis. So let's see here. We had some important points. We had 1, 2, 3, 4, and then we went up 1, 2, I think it was not quite 3-ish, and not quite -3-ish. So we did something kind of like this. I can't draw these for the life of me, but you kind of get the gist. So that was our cardioid. Remember, these graphs right here that are in this format, it says here the graph passes through the pole, so it's going to touch the pole in some way, shape, or form. And it's this little peak, okay? We are going to look at another graph in just a minute that looks very similar to this, but it doesn't go in at this peak. So in the heart, it goes in at a peak for a cardioid, okay? So that's it. That's a cardioid. You've seen a sine one. You've seen a cosine one. If you have time, play around and maybe do 2 plus 2 cosine and then do 4 minus 4 sine and see what that maybe does to your graphs. Okay, so there's going to be some stuff happening here, but you can play around with that on your own time. Okay, so there you have it, the cardioid.